Hey guys, let's go ahead and let's look at empirical rule. So I know the book only really gives you the theorem behind it, but I want to explain the theorem behind it. So we're talking about data that is bell-shaped, which means half the data is on the left of the mean and half the data is on the right, and it actually makes this pretty little bell shape. It's also called normally distributed, and we're going to hit this really hard in Chapter 6. So this is just a brief introduction. So if you look up here, these rules are the ones that talk about the ones in the book. So when we're talking about bell-shaped or normally distributed data, we can say 68% of the data lies one standard deviation from the mean. So what does that mean? So if you look down here at the area in pink, you can see that from the mean, which is the line in the middle, which is 0, what we do is we have the mean minus the standard deviation and then the mean plus the standard deviation on each side of the mean. If you add those up, it equals 68%. If you look at just the mean minus the standard deviation to the mean, it's 34%. All I did was divide it in half. So the next part of the theorem says that the two standard deviations from the mean is 95% of the data. So if you look at the red and the pink, and if you added 13.5 plus 34 plus 34 plus 13.5, you're going to see 95%. And you can see it starts where -2 is, which is the mean minus 2 times the standard deviation, all the way up to 2, which above that is the mean plus 2 standard deviations. So what we're doing is we're taking actual numbers and data sets and we're converting it to a z-score. And that's going to tell us a lot in Chapter 6, because then we can get really specific of what percentage of the data we're talking about. So let's talk about 3 standard deviations away from the mean. So if you go all the way from the left to the right, from the left where the blue is to the right to where the blue is, that's going to be 99.7% of your data. Look at it and you can see that it actually is that. 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 gives you 99.7. I actually went in and put the remaining amount, which is 0.3%, to make the distribution equal 100. And that's going to come into play when we talk about going to the left and going to the right. So if we come down here, we're going to use this score. So what is the z-score saying? In English, it says the data value minus the mean over the standard deviation. I wrote it below in the Greek letters, so I'm hoping it's not going to confuse you, but I'm going to show you some problems. All right, so here we go. If I said solve the problem from, if the mean is 500, the standard deviation is 100, what percentage are less than 300? Well, if you do, let me write this in here, if you do 300, oh, I did it down there for you. If you see here in the yellow, 300 minus 500 divided by 100, when you're putting this in the calculator, be careful, put this part in parentheses or it's going to give you a weird number. You're going to get -2. So go back up to this, and I want to see that it's less than, okay? You see here, less than, so what direction am I going to go for this one? I'm going to go to the left because it's less than. So I had a -2. So I want to do this area here in blue plus this little area here. So 0.15% plus 2.35% gives me 2.5%. Okay. So what if it said instead of less than 300, what if it said above 300? Well, you could do that. You could take, we already know that the z-score is -2, but I want to know what's above it. So I'm going to add the red plus the pink plus the blue up here and plus that little area right there to get my answer. So if I add it all together, I get 97.5%. Or I could do 100 minus 2.5% equals 97.5. I just took the remaining part that I didn't use. Okay? So what if the question said, what is the percentage between 300 and 700? Okay, so I would do 700. I knew what 300 was, remember, because I got 300. Let me put it down here to show you. 300 minus 500 divided, oops, let me put it in parentheses because I want you guys to practice putting in the calculator that way, equals -2. And 700 minus 500 divided by 100 equals 2. Okay, so I want the area between. So I'm going to come up here and look at my picture. So between -2 and 2, what do I get? I get 13.5 plus 34 plus 34 plus 13.5. If I add those together, I get 95%, which the theorem tells me. Oops, I spelled theorem wrong. There we go, theorem supports. Okay. So this is a tougher one, and I wanted to show you this because sometimes this will trip people up. So if your problem, for this problem, the mean is 79 and the standard deviation is 10. If you want to find the percentage below 69, so using your z-score, you go 69 minus 79 divided by 10. Remember, I'm going to put those parentheses in there to make your life easier. You get -1. So remember, I wanted to say below 69. Okay? So I'm going to go up here below 69, which was below -1. So I'm going to add up 0.15, 0.235, 13.5. And if I come down here and look, I get 16%. So my answer is, for the percentage below 69, is 16%. All right, I hope this helped. I'm actually going to post this paper onto the website, and I think it might help you guys. Thanks.